The turbocharger is a device fitted to an engine to compress and increase the amount of oxygen that enters the engine using the exhaust gas energy and thereby increasing the power output. Before we explain about how a turbocharger works, let's start about how the internal combustion engine works. In the naturally aspirated engine, the air flows to the engine because of the vacuum pressure created by piston movement downward. The fuel is injected and the mixture of air and fuel is burned and explode in the combustion chamber and push the piston downward. The energy from the combustion is used to rotate the engine rotor, heat, sound, and the remaining energy go to the exhaust gas. The amount of air sucked is limited by the pressure differences between the natural air pressure outside the engine and the vacuum pressure in the combustion chamber when the piston going downward. In a turbocharged engine, the turbocharger works by increasing the amount of air enters the engine by increasing the pressure differences between the intake air pressure and the vacuum pressure in the combustion chamber. This work done by putting a device that paired an exhaust gas turbine with the air compressor between the air intake line and exhaust gas line. The turbocharger works by capturing the exhaust gas energy flows outside the engine using a turbine. The exhaust gas energy rotates the turbine and the remaining energy go into the after-treatment system. The turbine rotation also rotates the air compressor because they are connected by the same shaft. The compressor rotation compress the air flows to the engine. When the naturally aspirated engine suck the air, the pressure outside is the natural air pressure. The turbocharger boosts this pressure to a higher level. Because of this, the pressure differences between the outside and inside combustion chamber is higher, so the amount of air entering the combustion chamber is also higher. Let's say when a naturally aspirated engine has a total displacement of 2 liters suck an amount of air, the turbocharger system makes the air sucked higher with the same engine displacement. So, the amount of air sucked by a 2-liter displacement of engine with turbocharger is same with the air sucked by a 4-liter displacement of naturally aspirated engine. The turbocharger increases the output power without increasing the engine displacement. The limitation of a turbocharger system is when the air is compressed, the temperature will increase and the air density becomes lower. The amount of air compressed is limited. Turbocharger engine commonly used by a diesel engine powered SUV. For the example is Toyota Fortuner Legender. To increase the air density even more in a turbocharger system, the turbo intercooler system is introduced. It's the law of physics. If we compressed an amount of air to a higher pressure, the molecules move more rapidly. The temperature of air is proportional to the kinetic energy of these molecules. Thereby, the air temperature will rise. One of the physical properties of air is the density will lower if their temperature rise. That's why the amount of air added only by compressing the air in a turbocharged engine is limited. The turbo intercooler system works by installing an additional device called intercooler or charge air cooler between the turbocharger and the engine. The intercooler then cooling the high-temperature air that's being compressed by a turbocharger. The lower temperature of air intake means the air intake is denser and the amount of air sucked by the engine is even more. This is an animation of how a turbo intercooler works. The engine that has been designed with a turbocharger and a turbo intercooler system from the start has many optimizations focused to increase the engine output even more for every displacement they have. When they compared to the older engine that's designed has been optimized for naturally aspirated air induction method.